So for this sum, we solve y equal to x plus 2 and x square equal to y to get the value of x as x equal to 2 and x equal to minus 1. Then when x equal to 2, if we use this equation, when x equal to 2, there should be clear diagram first. When x equal to 2, we have y equal to 2 plus 2, that is 4. And when x equal to minus 1, y is going to be equal to, so 2 points of intersection plotted over there, that minus 1, 1 and 2, 4. So required area going to be minus 1 to 2 y dx. I mean this line y dx minus parabola y dx. Isn't it? So x square by 2, x cube by 3, there it will be 4 minus 1 by 2, 2 plus 1, 8 plus 1. So there will be 6 plus 3 by 2 minus 3. Answer is 9 by 2 square unit. Keep your answer this manner always. Number 11, it is mod x plus mod y equal to 1. So by taking plus and minus signs before, remember we will be getting 4 lines over there. 4 lines involved with this equation are x plus y equal to 1, x minus y equal to 1, and minus x minus y equal to 1. Okay. So if we start plotting 4 lines,
so you can just take off the
yes. So we'll find the area of this whole region, means area we'll find in first quadrant, and from there we'll subtract the we'll multiply the area by 4, we'll get the whole area. This point is 1 0, this is 0 1, minus 1 0, 0 minus 1. So required area is going to be 0 to 1 y dx. And beside you will write all the lines you have taken. Obviously this is x plus y equal to 1. And this thing is x plus y by, x minus y equal to 1. This thing is minus x plus y equal to 1. This thing is minus x minus y equal to 1. These are 4 lines. So required area will be 4 times the y dx in the first quadrant. 4 times y in the first quadrant means this line, that is 1 minus x dx. So there it will be x minus x square by 2, 0 to 1. So there will be 4 into 1 minus half. This is equal to 2 square unit. Okay.
yes.
Now let us do number 12. Find the area bounded by the curves y greater than or equal to x square and y equal to mod x. Y greater than equal to x square, you'll be plotting this one as parabola y equal to x square first. X square equal to y. First you plot x square equal to y. X square equal to y, this we have discussed in many sums. Parabola like this. And y equal to mod x when you take, then it looks like this. This is y equal to x. This is y equal to minus x. And this is the parabola y equal to x square. You need to find sum of these two areas, isn't it? This is A, and by symmetry, area here, area lying here equal to area lying here, between this line and the curve. So by solving y equal to x and y equal to x square, we get x equal to x square. This implies x equal to 0 and 1. When x equal to 0, y equal to 0. When x equal to 1, y equal to 1. So coordinate of the vertex going to be 0, 0. A going to be 1, 1. By same manner, when you solve y equal to minus x, and y equal to x square, we have, so this implies x into 1 plus x 0, and when x minus 1, y is 1. So this point going to be minus 1, 1. Graph is symmetric. We'll find area in the first quadrant and then we'll multiply the result by 2. So the required area going to be, required area is equal to 0 to 1 straight line y dx minus parabola y dx whole dx. So this will be x square by 2, x cube by 3, answer is half minus 1/3, 1 by 6. The result you need to multiply by 2 because area is there in both the quadrant, first as well as in second. So answer going to be 1/3 square unit, this manner. A question automatically arises, where have I considered y greater than equal to x square? How do you understand that region will be this way? Why not this manner? Below it? That part you can check by taking points. If you take a point here, this point be say 0, 4. If you put x 0 and y 4, then 4 is greater than equal to 0. So region will be directed inward always. Okay? Region bounded by y greater than equal to x square will be here only, this part only. Not outer part. If outer part is there, a point like this, a common point, I am taking a x-axis point. Suppose I take 3, 0. 3, 0 must have satisfied. But 0 is not greater than equal to 9. So region cannot be below it, below x-axis or below the curve. It will be above the curve. Because if you take the point, it is lying in the region only. So this way you can verify. And this is the recent trend in board paper that they are asking questions based on inequality like this. Now let us go for sum number 15. Number 15, when you do, again the similar case, that y square less than equal to 4x. This you have to take, and less than equal to 9 by 4. If I think this manner, it will be 3 by 2 whole square. It looks like a circle if inequality sign is not there. It looks like a parabola if inequality sign is not there. Isn't it? But inequations are there. So I will suggest you to plot these two curves first. Y square equal to 4x. Then x square plus y square equal to 3 by 2 whole square. Then decide the region. Decide the region where they intersect. First, this one is a circle. Center is 0, 0, radius 3 by 2. All of you know it very well. Circle, this point is also known. 0 minus 3 by 2 and minus 3 by 2, 0. Okay. Now, we plot the parabola, but before plotting it, be sure that the point of intersection, where does it lie? So it's better if you solve these two equations. We are going to solve these two algebraically. Solving which two equations? Y square equal to 4x and x square plus y square equal to 9 by 4. If we put y square equal to 4x there, so this implies 4x square this is going to be 18x. So this implies 2x minus 1 into, so this implies x equal to half minus 9 by 2. There is no question of considering x negative because it's parabola y square equal to 4x. So parabola will go like this. This is parabola. You can write the equation side that y square equal to 4x here. And this circle is 9 by 4. This plotting all of you will understand. There is no problem in it because parabola, circle, you have done many sums. Now, your aim is, you will be doing everything with the pencil. No colored pencil is required. Just by using common pencil. But you must shade this one by putting dots. Or region must be shaded. The way you like, you shade the region. The graph has some lack of symmetry, but still, for exam purpose of view, this is okay. No one can be perfect in drawing this, not expected from you. So this diagram is enough. Now, two curves are symmetric about x-axis. We will take the advantage of this thing. When x is equal to half, y square equal to 4 into half. So y equal to plus minus root 2. If you say that, I will be taking this point as half comma root 2 and this point b as, this will be justified and this completes your steps of drawing. In exam, if you do this much, then examiner will be very satisfied with you. Okay. This point M I am unable to write. Here you will write, obviously the coordinate of the point M is half comma 0. All of you can see that this point M is half comma 0. So in future be ready to take a bigger diagram so that you can write everything over there. Your effort should be that to write the point M over there in the diagram. Okay. Now we have to check whether we have shaded the region properly or not. Because it was given y squared less than equal to 4x. Is the region totally lying inside or outside? That we must verify. If it lies inside, a point will satisfy. Let us check by taking an arbitrary point. Normally point we take on x-axis. This is advantageous because we can decide quickly whether region will be inside or outside. If there is a point, say 4, 0, you just put x equal to 4 and y equal to 0 there. What will you find? This part 0 less than equal to 16. This is true. So region will be inside. This way you can decide the region in which the graph lies. Alright. Now, that for circle, you take 0, 0. 0 square plus 0 square is less than 9 by 4. So all the points will be inside only, inside the circle and inside the parabola. As they are intersecting here, common region is going to be this only. O, A, suppose this point is P. So the common region is O, A, P, B, O. This is the common region. Even to do flawless calculation, you will write area of the region. We find area of the region O, A, P, B, O. This region. Then everything is very clear. So what we will do here, again we take the advantage of symmetricity of the curve. Y square equal to 4x, symmetric about x-axis. This line also symmetric about x-axis. So required area is going to be area in the first quadrant as well as area in the fourth quadrant. So you write required area is equal to 0 to half. I am going to consider this part first. 0 to half y dx of the parabola. Plus half to 3 by 2 y dx of circle. Alright. This integration all of you are familiar with. You can do it very well, I know. So you will complete the integration at home. But this sum is not completed here. This will be multiplied by 2. You must complete and you must check the answer. Next I am going to discuss with you this thing. Area of the circle exterior to the parabola. This is similar to the previous one. X square plus, this is sum number 18 from the textbook. X square plus y square equal to 16 and exterior to the parabola y square equal to 6x. Y square equal to 6x parabola is there and circle x square plus y square equal to 16 is there. So the question is little bit twisted for you. They have asked you to find area of the circle exterior to the parabola. This circle is drawn, parabola also drawn. Exterior to the parabola means you are going to find this area. Okay. So first tell me, is there basically any difference between the previous sum and this sum? By solving only we will get the coordinate of P and Q. Now we will have argument this is totally different because we have found this area. We found this area. But now they are asking different area. We found this area, really we found this area. You find this area again. Find this area. Follow the previous sum method. By solving you get the point of intersection, then integration this to this for this curve plus this to this for the circle. And then area of circle You know pi r square? (16 pi) is the area of the circle. Okay? 16 pi is the area of the circle. So, required area, this shaded area, required area going to be 16 pi minus area of this shaded region. Suppose you have got A. This minus A. So the answer will be 16 pi. Required answer will be 16 pi, that area of circle, minus area of parabola. By using integration, if you want to do, you can definitely do. But then, what you have to do there, by integration only, if you say that no, I'll stick to integration only. Whatever you say, I'll not listen, I'll do by integration only. So by integration, what will you do? You need to get point of intersection. You will write required area by integration only, no formula. Required area is equal to, see this point is 4, 0. So there it will be minus 4 to 4 circle y dx minus A. You'll find this area here by solving these 2 points. Then by integration you'll get and then do. And then I'd like to discuss number 19 so that this weekend you can complete. Monday only we'll discuss the doubts from Ncert, all sums, wherever you get stuck. If you don't ask me any doubt, then I'll start the next topic. Okay? So you have to finish the Ncert book at least by Monday. This is your work. I'll send you some other work also. So do number 19. Area bounded by the curve y equal to cos x and sin x between x greater than equal to 0 less than equal to pi by 2. I am using different ink for 2 different curves. First I will be taking this one. And before that, before you solve the problem, you just think, where does these 2 points intersect? These 2 curves intersect. Y equal to sin x and y equal to cos x. At which point they intersect? That is, when they intersect, sin x must be cos x. Tan x must be 1. So x must be pi by 4. Now let us plot the graph of sin x and the graph of cosine x. Do it for cos x first by using black ink. This is for cos x. I am not doing more, not required. But the region you are going to find, you need to say it properly. This is 0, this is pi by 2. This point is pi, this point is pi by 4. This is 3 pi by 2 for cos x. You write, this you have done for cos x. Cos x is represented by black one. And then we are going to plot sin x. Sin I am going by this green one. Sin x. Sin x will pass through origin, you know very well. At pi by 2 it has maximum value. My diagram is not perfect. This point little bit move to upward. You must not do. These two curves, they ask you to find the area bounded between these two curves between 0 and pi by 2. And bus between x equal to 0 and x less than equal to pi by 2. What is the area bounded between these two curves? So I think all of you have understood that you have to find this area as well as this area. Okay. So your answer will be 0 to pi by 4. 0 to pi by 4 cos x minus sin x dx plus pi by 4 to pi by 2 cos x minus sin x dx.